In this video, we are going to talk about synthetic division. It's the same process as synthetic substitution, but they do slightly different things. Synthetic substitution finds us a value at a specific x value, finds the output at the specific input. Synthetic substitution is going to be useful to help us factor things. It's not always going to be a factoring type question because division is slightly different than factoring, but it will help us in a factoring process to solve as we get further into this chapter. So, key part is our divisor must be an x minus h form, which means in number 36, h equals 2. Why that's important is that's the number that goes in my little window, my box, whatever I want to call it. Then I'm going to have my coefficients from each of the terms in the top part of that fraction, right, in the dividend. Now my process says bring this 1 down. 2 times 1, 2 from the little window, times 1 is 2. Add this column together to get 4. 2 from the window times 4 is 8. Add these together to get 2. 2 from the window times 2 is 4. Add these together to get -1. That's our process. So what this told us when we did synthetic substitution is that when x equals 2, we would have an output value of -1. But the reason why it's different now is if I look at this, I can't really plug in x equals 2 because I'm going to end up dividing by 0, which is not allowed. So I'm getting a separate polynomial. Starting from the right, this is going to be our remainder. Then it's our constant, our linear term, our quadratic term, and continuing up the power. So this is x to the 0, x to the first, x squared, etc. So when I divide this out, I'm going to end up with a 1x squared plus 4x plus 2, and then I have a remainder, which I write my remainders as a fraction. I could write plus -1 over x minus 2, but that's kind of, it's not wrong, it just feels wrong. So instead of writing plus negative, we just make it a subtraction problem, and that would be my final answer. Now in number 37 here, my h value is -2, okay? X minus h, so when it was x plus 2, that's like x minus -2. So in my little window, this time I have a -2, a 1, -1, -2, 8, using those coefficients. Just like before, make sure that if you are missing a power, like if there was no x squared term, you put a 0 in. It's an important piece. But here, bring down the 1, -2 times 1, -2. Add to get -3. -2 times -3 is +6. Add to get a +4. -2 times 4 is going to give me a -8. In this case, I get a 0 for a remainder, which is phenomenal. That just means that this will equal, well, this is my constant, linear, quadratic term. So 1x squared minus 3x plus 4. Okay? Probably the easiest way to write your resulting polynomial is to actually start on the right-hand side and work your way to the left, which feels weird. But if you're right-handed, now you can kind of get a glimpse into the life of a left-handed person where they have to write and drag their hand across everything that they wrote. So luckily you're on an iPad for lots of things, so you're not going to have to worry about getting your hand covered in pencil lead or ink or whatever. But it's probably easiest to start 4 here, say plus because it's positive, then minus 3x, then a plus x squared going that way, just so you don't have the wrong powered piece in place. Because the mistake that people are going to make is they're going to want what is supposed to be the remainder to be the constant. We start with the remainder, don't have anything else, work our way back. Probably not going to make that mistake. Okay? Have a great day, everybody.